Hello everybody, this is Mr. Yen, and this is the video for lesson 7.5. Make sure that you have the worksheet from Google Classroom. I'm going to switch over to that now. In today's lesson, we're going to be continuing our practice with triangle congruences. And first, we're going to review a couple of key vocabulary that you're going to be using today. The first is an isosceles triangle. An isosceles triangle is a triangle with two congruent sides. So in this diagram here, we can see the way that it's labeled that AB, that this side is congruent to this side. And the two sides that are congruent, we call these the two legs of an isosceles triangle. And the third side that's not congruent, we call this side the base. So in our isosceles triangle here, we know that side AB is congruent to side AC. The next term is a midpoint, and midpoint is the point on a line segment that divides it into two congruent parts. That's like saying dividing it into two equal halves. So in this example, M is the midpoint between B and A. And so if M is in the exact middle, then we know that this segment has to be congruent to this segment here. So we can say that B, the line segment from B to M, is congruent to the line segment from A to M. Two equal halves. A line of symmetry, this one we learned back in module 6, is a line that reflects a figure onto itself. If we look at this trapezoid here, and if we reflected this trapezoid across this line, it would reflect onto itself and stay in the same position. Another way that you can think of that is if we reflected this left side of this trapezoid across this line, it would reflect exactly onto this right side here. So the shape would be the same. Another way of thinking about a line of symmetry is that it's a line that splits a figure into two congruent parts, or two equal halves. So for example, this is a square and it has multiple lines of symmetry. Let's look at this line of symmetry right here. Notice how it splits this square into this half and this half. And both of these parts are going to be congruent. Right? All of this side is congruent to all of this side. And so this is a line of symmetry. And you could have also drawn a line of symmetry here, there, or going across that way too. Last one, and you learned this earlier this week, is the term corresponding parts of congruent triangles are congruent. In other words, you can think of this as saying, if two triangles are congruent, then all of their angles and sides are congruent. Corresponding parts of congruent triangles are congruent. Okay, So now that you have this down, let's take a look at number 1. For number 1, our given statement is that triangle EFG is an isosceles triangle. And we know that M is the midpoint of the base EF. And we're being asked to prove that GM is the line of symmetry for triangle EFG. So let's just start with the given information. Triangle EFG is an isosceles triangle. So EFG is, okay, so here's E, here's F, and here's G. So EFG is the triangle that goes between those 3 points. And we know that it's an isosceles triangle. If you remember from our definitions from the first page, an isosceles triangle is a triangle with 2 congruent sides. So I know that EG is going to be congruent to FG. And it's also telling me that M is the midpoint of the base EF. Remember, a midpoint from our definitions on the first page is the point in a line segment that divides it into 2 congruent parts. It's exactly in the middle. So M is the midpoint of the base EF. And then since M is the midpoint, I know that this segment has to be congruent to this segment. And then I'm being asked to prove that GM is the line of symmetry for triangle EFG. So I look at the triangle GM. GM is this line right here. And I want to prove that that's the line of symmetry. Okay, well, to do that, it's helpful to think about this question right here. To prove that it's the line of symmetry, what has to be true about this figure? Well, if you remember, going back to our definitions on the first page, a line of symmetry is a line that splits a figure into 2 congruent parts. That's the key part here. 2 equal halves, 2 congruent parts. So if this is a line of symmetry, that means everything on this left side has to be congruent to everything on the right side of this line of symmetry. And you can see that it's dividing this into 2 congruent triangles. So if this is a line of symmetry, I know that triangle EMF, that's this triangle on the left, EMG, has to be congruent to the triangle on the right. Right, this is the triangle on the left. And this is the triangle on the right. So triangle EMG has to be congruent to triangle FMG. If I can prove that these 2 triangles are congruent to each other, then I can prove that this is a line of symmetry. Okay. At this point, what I'm going to ask you to do is to actually, I want you to pause the video and then try the rest of this page on your own. So pause the video and see if you can finish the rest of this page on your own. And then once you're done, we're going to go over to the rest of this page. I'll wait for a moment and you can pause. Okay, now you are resuming the video after you've tried the rest of this page on your own, and you can check your work with me. Triangle EMG is congruent to triangle FMG. So I'm looking at these 2 triangles. So I'm going to start by listing the given congruencies that I have between these two triangles. I know that side EG is congruent to side FG. I know that side EM is congruent to this other side up here. So EM is congruent to FM. And then the third side that I have is this shared side between the two triangles. That one right there. So I can say that GM is congruent to itself. So I have a side, and a side. I have three sides that are congruent between those three triangles. So I can conclude that triangle EMG is congruent to triangle FMG. And I can conclude that they're congruent because they share three congruent sides, or side, 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 SSS for short. In the next part of this flow chart, once I've proven the two triangles are congruent, I can list the remaining parts that are also congruent. And I actually don't even need this as part of my proof because I've proven what I need to up here, but I'm going to list the remaining parts just for good practice. I know that angle GEM is going to be congruent to, so that's this angle, has to be congruent to this angle. So that's GFM. I know that this angle here has to be congruent to this angle here. So I'll say angle GME is congruent to angle GMF. And last, I know that this angle here has to be congruent to this angle here. So I'll say that angle, this is EGM, is congruent to angle FGM. Okay, those are the remaining parts of the triangles that I can also now conclude are congruent. Therefore, now, concluding statement. What was it that I wanted to prove? I wanted to prove that GM is the line of symmetry. This is what I wanted to prove. So I can rewrite that down here. Therefore, GM is a line of symmetry because, now the because statement, I've actually already written that out here. When it asks to prove that the GM is a line of symmetry, what has to be true? Well, this has to be true. So I can bring that argument again down here. So GM is a line of symmetry because triangle EMG is congruent to triangle FMG. That's what proves that it's a line of symmetry. Okay, and so that is the example of how you finish that first page. Now, I'm gonna have you finish number 2 and number 3 on your own. And with that, I will say goodbye and good luck.